This is Bob Capetta, and this is another example of linear programming in an applied context. So here's our question. A machine shop manufactures two types of bolts. The bolts require time on each of three groups of machines, but the time required on each group differs as shown in the table. So we have machine group 1, machine group 2, and machine group 3. Bolt type 1 requires a tenth of a minute on machine group 1, requires a tenth of a minute on machine group 2, and a tenth of a minute on machine group 3. Bolt type 2 requires a tenth of a minute on machine group 1, but 4/10ths of a minute on machine group 2, and 2/100ths of a minute on machine group 3. Now, what does the question say? Production schedules are made up one day at a time. In a day, there are 240, 720, and 160 minutes available respectively on these machines. What that means is machine group 1 has 240 minutes that we can use. Machine group 2 is available for 720 minutes, and machine group 3 is available for 160 minutes. Now, these bolts sell for different amounts. Type 1 bolts sell for 10 cents each. Type 2 bolts sell for 12 cents each. And the question asks us how many of each type of bolt should be manufactured per day in order to maximize revenue. So how many bolts of type 1 can we make? How many bolts of type 2 can we make so that we get the most money possible, yet we do not use more time than what's available by these machines? So I wanted to find my variables. I'll do that first. We're going to call X the number of type 1 bolts that we're going to produce, and Y will be the number of type 2 bolts that will be produced. So for each type 1 bolt, we need a tenth of a minute on machine 1. For each type 2 bolt, we need a tenth of a minute on machine 1 as well. So a tenth of a minute times the number of machine 1 bolts plus a tenth of a minute times the number of machine 2 bolts will tell us how much time we're using on machine 1. So notice machine 1 group 0.1x plus 0.1y. What's our total for machine 1? 240, which we'll see here shortly. Now how about machine 2? 0.1 for each bolt of type 1, so 0.1x. 0.4 for each bolt of type 2 plus 0.41y. That's the total amount of time on machine group 2. And what do we have total for machine group 2? The question says 720 minutes. And then similarly for machine group 3, 0.1 for each type 1 bolt, so 0.1x, plus 0.02 for each type 2 bolt, 0.02y. 0.1x plus 0.02y. How many minutes do we have in machine group 3? A total of 160 minutes. So looking at this, we have our time on each of these three groups with our 240 for the first, 720 for the second, and 160 for the third. So we can use up to 240. So we have an inequality, machine group 1, 0.1x plus 0.1y less than or equal to 240 minutes. Similarly for machine group 2, 0.1x plus 0.4y less than or equal to 720 minutes. That's what we have available on that group. And for machine group 3, 0.1x plus 0.02y less equal to 160 minutes. These are three constraint equations. Now, of course, the number of bolts has to be positive, or at least non-negative. X greater or equals 0, Y greater or equals 0, which is often the case in our linear programming problems. Now, we want to maximize our revenue. So remember, here's our question. What's our revenue? Type 1 bolts sell for 10 cents each. Type 2 bolts sell for 12 cents each. X is the number of type 1 bolts, so we get 10 cents for each type 1 bolt, 10 cents for each X, so 10X, 12 cents for each type 2 bolt, 12 cents for each Y. So knowing that, then our revenue is going to be 10X plus 12Y. That's what we are going to try to maximize. Subject to what constraint equations? Subject to all of these constraints that we showed earlier. Our group 1, our group 2, our group 3 machines, as well of course the fact that X and Y have to be positive. So we will add in the important constraint that x and y are both greater than or equal to 0. So our next job is to construct the feasible region. We need to look at each of these three inequalities, draw the line, do the appropriate shading, and find out what's common for all three of those. So we start with this inequality. That was our our machine group 1 constraint equation. Let's graph it as an equal sign, and I will do that using intercepts as we saw in a recent video. So if x is 0, plug 0 in for x. 0.1 times 0 plus 0.01y is 240. So 0.1y is 240. Dividing by 0.1, we get y is 2400. So when x is 0, y is 2400. Now let's go ahead and plug in a y of 0. That'll give me 0.1x plus 0.1 times 0 is 240. So 0.1x will be 240, similar to that one, right? So 240 divided by 0.1x is also 2400. So we have those 2 points, the y-intercept and the x-intercept. Which way are we going to shade? Towards 0, 0 or away from 0, 0? So I'm going to call 0, 0 my test point. If I plug 0, 0 in, do I get a true statement or a false statement? 0.1 times 0 plus 0.1 times 0 is 0. Is that less than or equal to 240? Of course it is. So 0, 0 gives us a true statement, so we shade towards 0, 0. So again, there is our inequality. 0.1 times 0, 0.1 times 0 less equal to 240, 0 less equal to 240. Yes, that's true. We're going to shade towards 0, 0. So try to visualize this. X-intercept at 0, 2400. Y-intercept at 2400, 0. We're only in the first quadrant. Remember, x and y have to be positive. We can't make negative bolts. For this to be reasonable, both x and y have to be positive. So what is that graph going to look like? Like this. Here's 0, 2400. Here's 2400, 0. We are shading towards 0, 0, shading this way in the first quadrant, and we get this nice triangle. So that's our first constraint equation. Let's take a look at our second one. The process is identical. So here's our second constraint for machine group 2. This is our inequality. We're going to first graph the line as an equation using our procedure of intercepts. Plugging in 0 for x, 0.1 times 0 plus 0.04y is 720. 0.4y is 720. 720 divided by 0.4, 1800 is y. Plugging 0 in for y, 0.1x plus 0.4 times 0 is 720. So 720 divided by 0.1, we get x is 7200. And we're going to test 0, 0 again. Let's think about this. 0.1 times 0 plus 0.4 times 0, is that less than or equal to 720? Is 0 less equal to 720? Of course it is. So again, we're going to shade towards 0, 0. So just to emphasize that, testing 0, 0, 0.1 times 0 plus 0.4 times 0, is that less equal to 720? Of course it is, so we shade towards 0, 0. So let's visualize this if we can. If x is 0, y is 1800. If y is 0, x is 7200. And shading towards 0, 0 in the first quadrant. Here's 0, 1800. There's 7200, 0 shaded towards 0, 0 gives us this triangle. So that's two of our constraints. We have our third constraint equation for machine group 3. And by now you should be familiar with our process. We are going to solve it as an equation using intercepts. If x is 0, what do we get? 0.2y is 160. Y is 160 divided by 0.02. Y is 8,000. If y is 0, what is x? 0.1x plus 0.02 times 0 is 160. 0.1x is 160. X is 160 divided by 0.1. X is 1600. So we've got 0, 8,000. We've got 1600, 0. And again, you'll see we're going to test 0, 0 to see our direction of shading. 0.1 times 0 plus 0.02 times 0 is certainly less than 160. So again, 0 less than 160, we're going to shade towards 0, 0. Let's look at a quick graph there. Try to visualize it in your mind first. X is 0, Y is 8,000, X is 1,600, and Y is 0. What does that look like? There we go. Shading toward 0, 0 gives us this triangle. Now, we actually had 3 lines for our 3 constraints. I'm calling them line 1, line 2, and line 3. And I want to look at all them and see what's common, what part of the region is true for all 3. Remember, we always shaded toward 0, 0. Always shaded toward 0, 0 in the first quadrant because X and Y have to be positive. So L1 is the red line. L2 is the blue line. L3 is the green line. And this region down here is what is under all 3 of those lines. So let me go ahead and zoom in on that portion. This portion will be our feasible region, and we need to find the corner points. So here is that zoomed in piece. Now you'll notice I have a corner point here. The blue line, L2's y-intercept. L2's y-intercept is 1,800. Green line's x-intercept. Green line, L3's x-intercept is 1,600. Of course, 0, 0 is here. So we get 3 corner points fairly quickly. These 2 are corner points. We're going to need to figure those out. This one is not a corner point. This is the portion that is bounded by all of the constraints. This is not. This one is on the other side of the red line. So this is not a corner point. These 2 are corner points. We need to do some algebra to find them. Again, there is the y-intercept for the blue line for L2 and the x-intercept for the green line, L3. How do I find these 2? I have to look at the intersection. So the intersection of L1 and L2, red and blue here. Intersection of L1 and L3, red and green here. So these are the other 2 corner points we're going to need to test to see where we have our maximum revenue. So here's L1 and L2. Again, what were those? That was red and blue line. I'm going to solve this by elimination of variables. You'll notice they both have a 0.1x. Let's get the 0.1s to cancel. I wrote L2 first. 0.1x plus 0.4y is 720. I wrote L1 second, but multiplied the entire equation by -1 to get the 0.1x's to cancel. So the first equation stays the same. Second equation becomes negative 0.1x minus 0.1y equals -240. So if we add these together, the 0.1x's cancel. 0.4y minus 0.1y is 0.3y. 720 minus 240 is 480. Divide both sides by 0.3, and I get y is 1,600. So I've got to plug that y into one of these equations to solve for x. I've chosen to use the 720, line 2. So I'm going to plug 1,600 in for y here, and then I'm going to solve for x. So 0.1x plus 0.4 times 1,600 is 720. 0.1x plus 640 is 720. Subtracting 640 from both sides, 0.1x is 80. Dividing both sides by 0.1, and I get x is 800. So that corner point, line 1 versus line 2, the x is 800 and the y is 1,600. So let's see that on our graph. We'll add that to our list of other corner points. That's right here, 800, 1,600 to go with those 2 intercepts and a 0, 0. And the last one I need to find is this one, red versus green. So that's line 1 versus line 3. And I'm going to solve that intersection point the same way with elimination of variables. So line 1 is 0.1x plus 0.1y is 240. Line 3 is 0.1x plus 0.02y is 160. So I wrote line 1 first, I wrote line 3 second, and I'm going to again multiply by -1 to get the 0.1x's to cancel. So the first line stays the same. The second line, -1 times 0.1x, negative 0.1x, -1 times 0.02y, negative 0.02y, -1 times 160, negative 160. Now, be careful. 0.1x minus 0.1x, those go away, those disappear. But 0.1 minus 0.02, remember that's 0.10y minus 0.02y, which will give us 0.08y. So just be careful with that. Use a calculator if you have to. 240 minus 160 is a total of 80. So to solve for y, we will divide both sides by 0.08. We get y is 80 divided by 0.08. Y is 1,000. So we're going to plug the y into one of these equations. I chose to use line 1. Plug the 1,000 in for y. So we get 0.1x plus 0.1 times 1,000 is 240. 0.1x plus 100 is 240. So 0.1x is 140. If I divide both sides by 0.1, I get x is 140 divided by 0.1 is 1,400. So we have the x value is 1,400. We have the y value is 1,000. So that is my last corner point, I believe. So let's go ahead and look at that with all the lines. So 1,400, 100, again, red, line 1 versus line 3, green is here. Line 2, blue versus green, is not a corner point. My feasible region is what is under all 3 of those lines. This is my feasible region. So based on the constraint equations, we found the feasible region. Now our goal is to maximize the revenue. So recall what that was. Here was our original question. Maximize revenue, which was 10x plus 12y, because we had 10 cents for each type 1 bolt, 12 cents for each type 2 bolt. So I've got to look at the revenue values for each of the corner points. So we're going to go ahead and do that. We're going to make a table for each corner point, plug in our various values and see what we get. Now our trivial corner point, we're making 0 type 1 bolts, 0 type 2 bolts. Our total revenue is 0, no surprise. Our next corner pointer is 0, 1,800, right? We see 0, 1,800 right there. So 0, 1,800 gives me 10 times 0 plus 12 times 1,800, 21,600 cents, or $216. Our next corner point after that is going to be 800, 1,600, which is here, this spot, that corner point. So 800, 1,600, 10 times 800 plus 12 times 1,600 gives us 27,200 cents, or $272. So that's a little bit more. Our next one is 1,400, 1,000, which gives us 26,000, or $260. And then our last corner point here is just 1,600, 0. 10 times 1,600 plus 12 times 0 is 16,000. Now we're looking for the maximum revenue. Which one of these gives us the largest number? That would be 27,200. So 27,200 cents is our maximum revenue. Remember, here was our original question. X represented the number of type 1 bolts. Y represented the number of type 2 bolts. Type 1 bolts sold for 10 cents each. Type 2 bolts sold for 12 cents each. So 10x plus 12y represents cents. That's important for us to know. We said our maximum was 27,200 cents. So what does that tell us? Well, our maximum revenue of 27,200 occurs when x is 800 and y is 1,600. But you should always refer back to the original context of the problem. X represents the number of type 1 bolts. Y represents the number of type 2 bolts. So our conclusion should be in words, and it's going to state, we have a maximum revenue of 27,200 cents, or preferred, $272, when 800 type 1 bolts from X are produced, and 1,600 type 2 bolts are produced. And that will conclude this challenging lesson.